All right, that sound means it's time to get started. Hello, everyone. Good morning, good evening, wherever you're tuning in from. Welcome. My name is Tiffany Palino. I'm the manager of pre-nursing and continuing education services here at Archer, and I am happy to be here with you all. Thank you for tuning in. If you're on Zoom, if you're on Facebook, if you're on YouTube, welcome, welcome. So today is going to be really interactive, okay? I have some practice questions for us to go through in this half hour together. So, TEAS and HESI practice questions. So, remember, TEAS and HESI are your entrance exams. So, these can be kind of tough questions sometimes. So, the goal today is to help you feel comfortable with all these types of questions that you'll get and that you'll see on the TEAS and HESI exam. Now, I did focus on more science-based today, and so that's what today's session is kind of going to be focused on. Remember, practice is key to success, so stay engaged, think critically, and don't hesitate to ask questions as we move along. Let's make the most of our 30 minutes together today. So, if you do have questions, you can go ahead and type it in the chat or the comments, but let's get started. So we're going to start with our tease questions first. And science is the topic I decided to start with. Okay, so let's start with our first practice question. Now, remember, before we begin, try to think to yourself, and I want you to only spend about a minute at most on each question. That is a good strategy in either the TEAS or the HESI exam to make sure you stay within those time requirements. So, about a minute on the clock, guys. Here we go. Which regions of the humerus are described when referring to its distal and proximal ends? Distal and proximal ends. So take a moment, read through those answer choices, less than a minute on the clock. Type in the chat if you know, or in the comment section. Any ideas? Okay, a couple guesses. I see a couple guesses here. One more second. If you guessed epiphysis, you are correct. Good job. So here's a picture here of the humerus. So it's the distal and proximal ends of the long bone, including the humerus. So it's important to remember this when discussing bone structure because these are crucial for bone structure and bone growth and bone function. Now, it's really good to look at all the other answers too to kind of see why the other answers are not correct. So, diaphysis refers to the shaft of the bone, not the distal and proximal ends, because remember, distal and proximal are the ends, right? Medullary cavity is the space inside the bone that contains the bone marrow. And then we have D, the metaphysis, is the transitional area between the diaphysis and the epiphysis. So, understanding all those key terms, super important. If I was studying this, I might want to make some flashcards. I'd put the term on one side and the definition on the other. All right, great job, great start. Let's go to our second question. Sticking with the science theme. What is the name of the standard reference position used in anatomy? What standard reference position do we use when we're talking about anatomy? Is it horizontal, supine, anatomical, or prone? Couple answers in the chat. Good job, you guys. And then how about on Facebook or YouTube? Go ahead and type that in the comment section. Give you a moment. Remember, less than a minute is ideal with these practice questions. Okay. If you answered C, anatomical, you are absolutely correct. So, the anatomical position is like universal language, right? So very good. It's like universal language that we use when we're talking about the body. So, whenever medical professionals or students or anybody is describing the location of structures, they are using this standard position for their reference. Very good. So remember, in this position, the body is standing upright with the feet together and the arms at the side, and they're facing forward. It ensures clarity and consistency. Super important that we're all being consistent when we're talking about the human body. Now, other positions like supine or prone, supine, I always think about soup, holding a can of soup or a cup of soup, keeping everything kind of up. So you're lying and facing upward. When prone is quite the opposite, you're laying on your belly. And then there was the horizontal position. That's referring to the orientation, not necessarily positioning. All right, off to a great start, everybody. So let's move on to our third question. Which anatomical plane divides the body into equal right and left halves? So we're talking about this division here. Which one is it? Mid-sagittal, coronal, transverse, or oblique? Which anatomical plane divides the body into right and left? Take a moment, less than a minute. All right, just a few more seconds for some others to answer. Yes, you're getting it. Everyone in the chat here and comment section. Great. Excellent. Yes. Mid-sagittal. If you guessed mid-sagittal, you are absolutely correct. So the mid-sagittal, this is crucial. It needs to neatly divide that body into the right and to the left side because we need to make sure everything is symmetrical. And that's what this is. It's a reference point for symmetry. Now, it's important to contrast this with those other options, right? The coronal option or frontal plane splits the body into front and back. So that would be if I were to draw a line here at the top of my head and have the front of my body and the back of my body. The transverse or horizontal is when you divide it into upper and lower. Think of it like slicing someone in the middle of their stomach, like magicians do sometimes on magic tricks, right? That's how I remember transverse. And then finally, oblique, it's at an angle. It's nothing equal, it kind of cuts at an angle. I kind of think of obliques, right? We have oblique abdomen or muscles, and sometimes they can make curvatures. So that's how I remember that one. Understanding this is super important because we need to understand how the body is divided. I'm doing, someone's asking, I'm doing TEAS first and then I'll be doing HESI next, but these are for the entrance exams, not for the exit exams. Exit exams are more nursing, school related. These are entrance exams. Good question for pre-nursing. Okay, next question. The skin is blank to muscle. So think about what is it in relation to muscle? Superior, superficial, proximal, or posterior? The skin is blank to muscle. Really quick answers here in the chat on Zoom. Awesome. Great. You guys all got it. Waiting for some of you on Facebook or YouTube. Okay, excellent. Great job. You got it. If you guessed superficial, you are absolutely correct. So we're diving right into this. So it's that spatial relationship between the skin and the muscles, right? Superficial. This means the skin is outside or closer to the body surface than the muscles. Think of it like the layers of an onion. The skin is the outermost layer. So we have to talk about those incorrect answers, right? Superior is something higher up. or closer to the head? It doesn't really fit when discussing layers, skin versus muscle here. Proximal is all about the limbs. So closeness to the torso or farther away, right? And then posterior and anterior is really front and back. It doesn't really have any reference to the skin and the muscles. So when you think about the skin and the muscles, superficial is the best answer here. Great job. Everyone is doing great. That was our fourth question for T's. Let's do another question. So, which of the following defines a chromosome? Which of the following defines a chromosome? Take a moment. These are a little bit longer answer choices. I want you to read through them. Pretend like you're taking the test right now. A minute on the clock. A few more seconds. Oh, this one got a lot of you. A chromosome, a chromosome. You want to think about these words here, okay? I got a little bit of everything, it looks like. A little bit of everything. So look, it's B. Condensed structure of DNA. If you said B, awesome job. Condensed structure of DNA and proteins like histones that become visible during cell division. Chromosomes help organize and segregate genetic material. So they are crucial players in cell division. But think about that they only become visible when the cell is about to divide. Now, why does this matter? Well, during processes like mitosis and meiosis, chromosomes ensure that genetic material is organized and segregated accurately. And it's vital for cell function and reproduction. Now, A refers to a gene, which is a smaller component of DNA. C describes the genome, which encompasses all genetic material. And then D is chromosomes include both coding and non-coding, not just coding DNA. That's why that one was wrong. So I hope we understand that. Understanding this is super important, especially genetics, and making sure that kind of terms are understood. So again, if I were studying this, I would put one term on one side of a flashcard and the other side, I would give a brief description to help me kind of study for this. Okay, those are my T's specific practice questions related to science. Now I'm going to go to my HESI ones, which can be still potentially on your T's as well, but let's get into these. These are sometimes a little bit more in depth. So, what physiological response occurs when the body temperature rises above 37 degrees Celsius to maintain homeostasis? So, that's about 98.6 degrees Fahrenheit. Maintaining homeostasis. So, what happens? Take a few moments here. You're doing great. Okay, couple answers in the chat. Couple answers online here. Let's see, this one's tough, right? Homeostasis, maintaining homeostasis. So when the body temperature is up, what happens? What's our physiological response? What ends up happening to the body when the temperature is high? All right, it's been about a minute. So if you guessed B, you are correct. Let's take a closer look at this one. I think this one was tough. So our body temperature goes up. Eccrine sweat glands. So sweat glands kick into action. So has anyone ever had a temperature? Did you ever break out into a sweat? Think about it that way. Sweat is used to kind of cool down the skin, right? It wants to bring that temperature down. This is a prime example of homeostasis. We want to kind of balance that temperature. And we want to maintain that internal environment that our internal organs, everything stays kind of at a equal temperature. We don't want anything to get a little too hot. So remember, sweating helps cool the body down. So the other options, option A suggests that blood vessels constrict in heat, but in reality they dilate. Someone just typed that in the chat on Zoom. Yeah, they dilate. Option C mentions sebaceous, sorry, I can't say that right now, glands producing sweat, but these glands actually release sebum, which is oil. So it's not involved in the cooling stage. So maybe we were just were mixing up what glands release the sweat. And then option D, this is a misconception about blood vessels constriction, which actually happens in response to cold, not to heat, which is when the body would shiver. That would be a homeostasis response, right? The body would shiver to kind of warm up. All right, great job, guys. So let's get on to the next one. Again, about homeostasis, keeping this homeostasis party going. Practice question 2 for HESI. Which of the following is an example of homeostasis? Okay, less than a minute on the clock. Read through these. I might have just given you this answer with what I just talked about. Hopefully I did. Homeostasis. Keeping everything, balancing everything out, right? What do we think? What do we think? Yeah, you got it, Christelle. Yep. All right, a few more seconds, 10 seconds. So this one, anyone pick C? C is the correct answer here. Yes. Excellent. So, why, right? Why is that right? When the body detects a drop in body temperature, what ends up happening? Things constrict, vasoconstriction, which helps reduce heat loss. It helps maintain stable internal body temperature. This is a great example of how our body works to keep its internal environment. Remember, we want to keep everything inside, all those vital organs balanced, which is the key in homeostasis. Now, A. So, melanin production due to UV exposure is a protective mechanism, not necessarily homeostasis. Homeostasis, think of balancing or counteracting whatever's going on. Option B, the natural aging process, right? We naturally lose elastic and collagen, but that doesn't really contribute to stability or internal stability. Homeostasis is all about balance. So this is true. It is something that happens, but it's not necessarily considered homeostasis. And then finally, D, sebaceous glands producing sweat. It's actually the acrine glands or acrine glands that we just learned in the previous question. That is the gland that handles sweat production. Okay, now this is a kind of a memorizing question. So we just have to know this answer. Here we go. Question number 3 for HESI. How many pairs of chromosomes do humans have? How many pairs of chromosomes do humans have? Pairs of chromosomes. 22, 23, 24, or 46? 22, 23, 24, or 46? Spend less than a minute answering this one. How many? Oh, I'm getting a lot of different answers here. Hmm. How many chromosomes? Chromosomes is the question. Chromosomes. What do we think? What do we think? What do we think? If you guessed B, you are correct. 23. Okay, so 23. Humans have a total of 23 pairs. That's 22 pairs of autosomes and one pair of sex chromosomes. That's why it equals total together that 23. Now, the 46 is the total chromosomes in each human cell. So that one was a little tricky, little tricky. A is incorrect because remember 22 is just those autosomes, so it doesn't include the sex chromosomes. C is incorrect because we don't have 24 pairs, we have 23. And then D, we already talked about 46 is the total. Very, very good. It's really, really fascinating. I find how our genetic blueprint is so neatly organized into these pairs. Isn't that cool? Each pair is one chromosome from your mother and one chromosome from your father. I just think it's so interesting how this makes up who we are. It's just so cool. Science can be really cool, right? It's just, it's an amazing. Okay, great job. Keep it up. Let's keep going. Question number 4 from Hesse. What are the primary functions of carbohydrates in the body? What do carbs do in the body? What do carbohydrates do in the body? What's their primary function? Take a few minutes here. Not a few minutes, sorry. Less than a minute. Practicing less than a minute. That's why I'm going kind of fast. Primary function of carbs. Hmm. Structure, communication, storage, protein synthesis and enzyme activity, DNA replication, generic storage, hormone production, and cell signaling. If you guessed which one you think, I'll give you 5 more seconds. 5 more seconds on this. 4, 3, 2. If you guessed A, you are correct. A. So, carbohydrates, these are essential. First, they provide structure and support. That's crucial for maintaining the integrity of cells and tissues. Next, energy, right? Maybe you all were looking for that energy answer, but it wasn't there. So, they store energy in our body and it can readily we can readily access it when needed, right? So if we don't have carbs, then we're not going to have a lot of energy, so the energy levels would be a little inconsistent. Third thing they do, communication. They assist in signaling recognition processes, which are fundamental in cellular interactions. So very, very important. Carbs are super, super important. Support, store energy, and play a role in communication. Now, proteins, nucleic acids, and lipids have their own roles in the body. We think about our macronutrients, so they all do a little something different. That's where those other answers were. So, carbs, carbohydrates, support structure of cells and tissues, store energy, and play a role in cell communication. Very important. Excellent. Okay, let's move right along here. Question 5 for Hesse. What is a dominant trait? What does it mean to be a dominant trait? Dominant trait. Someone's asking in the comment section. Today's presentation right now is about TEAS and HESI, so it's for the entrance exams for pre-nursing students. But it's pretty good practice to review some science. I also have some bonus math coming up if anyone wants to stay tuned for that. Okay, so what is our answer here? Dominant trait. If you thought B, you are absolutely correct. It is expressed when at least one dominant allele is present. This is fundamental in genetics. So we need dominant and recessive, right? So the other ones, A is recessive, C is is suggests that dominant traits come only from the mother, but they actually can be from either parent. And then D confuses mutations with ALS interactions. So dominance is not dependent on mutations. Okay, so I did just mention I got some bonus math, okay? Who doesn't like math? I personally love math. So remember, you can get math questions on your exam, especially on the entrance exam on the HESI A2. You could have some potential dosage questions. So I have some questions here. Let's dive in. A charge nurse's shift ends at 7 p.m. What is the equivalent time in military notation or military time? What is the time in military time? If it's 7 p.m., what is that in military time? Military time, 7 p.m. in military time. Remember, spend less than a minute if you can. Yes, awesome job, Nina, Victor. Good. All right, a few more seconds here. Good job, Casey. Yes, Doris. Good, good, good. Good. So 1900. Awesome. So let's just talk about military times real quick. So remember, after noon or 12 p.m., that's when you add numbers to it, okay? So simply you can add 12 to something. So for example, if this shift ends at 7 p.m., we add 7 hours to 1200, basically, because 1200 is 12 p.m. And that gives us that 1900. This method ensures that every hour is clear and consistent. So as we move forward, we're going to see how AM times are represented, which are a little different than PM times. Now, any of you who have a cell phone out there, what I always recommend my students do is turn your clock to military time so you can start to get used to what that's like. There's a feature on your cell phone where you can have your clock in military time. If that works for you, if military time is still kind of confusing, the easiest way to practice is to continue to see it. Okay, let's try another one. An IV for a patient begins at 9 a.m. What is the equivalent in military time? 9 a.m. in military time. How do you write it? How do you write 9 a.m. in military time? That's what I want you to focus on. 9 a.m. 9 a.m. 9 a.m. in military time. So we have to be careful about how we write it, okay? Military time, you're going to just, good. You're going to add that zero before, okay? 0900 is how you might read this. So morning or AM, they remain the same. All you do is add that zero before. And if you notice, we don't have the colon in our answers. So some of you all are typing it in your answers that you're having the colon here. What do I mean by that? See how this is written? There's no colon here. We don't put those dots, okay? It's not relevant in military time. You only put the 0900. Very, very good. So whenever you see something like 900, 0900, just remember it's straightforward. It's just 9 a.m. Okay, make sure you understand that. Just 9 a.m. All right, we're gonna finish with a little bit of a hard one. Not time, okay? This is I'm gonna do this one. This is a conversion. So a newborn weighs 8 pounds and 3 ounces. What is their weight in just ounces? We're going to end with this one. Kind of a tough one. So we have 8 pounds and 3 ounces. What is it in just ounces? How many ounces does this baby weigh? Take a few minutes. I guess what's important here is understanding how many ounces are in 1 pound. How many ounces are in 1 pound? And then once you can figure that out, Then you'll be able to hopefully solve for the rest. Any answers? Yes, you. Sorry if I said your name wrong. Kip, I'm going to call you Kip. Yes, you are correct. Any other answers? Type them in the chat or in the comment section. Okay. So we want ounces. That's what we want is ounces. We want ounces. Okay. And we have 8 pounds and 3 ounces. So we need to convert those 8 pounds to ounces. Okay, just a few more seconds here. Gonna see if anyone else gets this. All right, if you guessed 131 ounces, you are absolutely correct. So let's talk through why. So 1 pound is 16 ounces. So what do we have to do? You have to multiply 16 times 8 to get however many ounces, right? But then that's 128. But then remember, the baby is 8 pounds and 3 ounces. So we have to add 3 to that. And that's where we get the total of 131 ounces. This is accurate, okay? Especially when we're converting weights. You need to make sure you understand everything step by step. So if we need ounces, the key here is to convert everything into ounces. Okay, so 16 ounces is 1 pound. 16 times 8 is 128. Then we have to add the 3 and we get 131 ounces. Very good. If you struggled with that a little bit, practice, practice, practice. Practice, practice, practice. Okay. Well, we are at the end of our session today. I just want to thank you all so much for being here, being interactive. I hope this was helpful. We are going to have another TEAS and HESI session next month. And I think I am going to do more practice questions because I think this was helpful. So if you need anything, um, feel free to reach out to me. My name is Tiffany Palino at archerpulse.com. So feel free to email me and I'm happy to answer any of your TEAS and HESI questions. Good luck, everyone. You're going to do great. You're going to pass these exams and we are here to help you. Take care, everyone. Have a great day. Bye now.